Okay, in order to build our unit circle, we're going to have to review our trigonometric ratios, which are sine, cosine, and tangent. You might not have seen these for a while, or you might not have seen these at all. So let's define them, okay? So sine, we always say sine of an angle. Okay, that angle is usually given a name that's a letter. Okay, and it is the length of the side opposite divided by the length of the hypotenuse. Okay. All right. The next one is cosine of an angle. And that's the length of the side of what we call adjacent. Divided by the length of what we call the hypotenuse. And we'll review what those are in a minute. Okay. And then the last one is called tangent of an angle. And that is the length of the side opposite divided by the length of the side adjacent. Okay, so there are abbreviations for this. Sine, okay, sin, okay, angle A, and we say op over hype. Cosine is cos A, adjacent over hypotenuse. Okay, tangent, angle A, opposite over hypotenuse. You might have heard your teachers use the phrase SOHCAHTOA to help you remember what these mean. Okay, so what we're going to do is we're going to find sine, cosine, and tangent for our special right triangles, which are slightly above us, and then we're going to use those to help us with our unit circle. Now, the great thing is that the sine, cosine, and tangents are functions of the angle. So if you have a 30-degree angle, its sine ratio will always be the same, okay? So I don't care how big the triangle is, the sine, cosine, and tangent ratio of your angle measures will always be the same, okay? And this is going to help us build that special right triangles and our unit circle. Okay, here we go. So this triangle on my left is my 30, 60, 90. Okay, and if I remember from the previous video that this was a 1, this is a radical 3, and this is a 2. Okay, now, so first we're going to use our 30-degree angle. So we're going to find sine of 30, cosine of 30, and tangent of 30. Okay, now, so usually what I have students do is I have students label the hypotenuse first. Okay, because the hypotenuse never changes. The hypotenuse is always the hypotenuse. It's the longest side that's opposite the 90-degree angle. Now, depending on what angle you use, that's going to change who your opposite side is and who your adjacent side is. So since I'm using the 30, the 1 will be the opposite side, and then the radical 3 would be the adjacent side. Okay, so using my ratios, sine of 30 would be opposite over hypotenuse, which would be 1/2. Okay, cosine of 30 adjacent over hypotenuse, radical 3 over 2. Tangent of 30 opposite over adjacent. Now, this is where we get a little tricky. Okay, it's 1 over radical 3, which is a perfectly okay answer, but this is what we call unrationalized. Okay, we can work on rationalization later, but if I were to rationalize this, my answer would be radical 3 over 3. Okay, so it kind of depends on, your teacher. Some teachers really like rationalization. Other teachers really don't, mind if you leave it a little bit sloppy, I guess, or kind of unrefined, as it were. Okay, so now what we're going to do is we're going to switch angles. Okay, we're going to use 60. So if I'm referencing 60, okay, the opposite and the adjacent switch. So opposite the 60 would be the radical 3. And then adjacent to the 60 would be the 1. Okay, so let's find sine of 60, cosine of 60, and tangent of 60. Oops. So cosine of 60 would be radical 3 over 2, opposite over hypotenuse. Remember, hypotenuse is always the same. Cosine of 60 would be 1/2. And tangent of 60 would be radical 3 over 1, or just radical 3. Okay, now take a moment and look to see if there are any patterns between the 30 and the 60 that could help you out. Okay. And then we're going to deal with the 45, 45, 90. Okay, I'm going to put, no, I didn't want to do that. There we go. All right, I'm just going to put kind of like a line separating the two so we don't get too confused. Okay. All right, now let's talk about our 45, 45, 90. If you remember from the top, 90 degree here, this was a radical 2. This is a 45, and this is a 45. This is a 1, and this is a 1. Now, the 45, 45, 90 is your friend, okay? Because there's only one angle that we can take the sine, cosine, and tangent of, and that's the 45 degree angle. So we choose 1. Doesn't matter which one. Okay, this is the opposite. This is the adjacent. And this is the hypotenuse. Okay, so we're going to find sine of 45, cosine of 45, and tangent of 45. Okay, so sine of 45 would be opposite over hypotenuse, which would be 1 over the square root of 2, or if we rationalize, square root of 2 over 2. Either one is fine, but please be careful. Teachers and possibly Edgenuity might like the radical 2 over 2 better. Okay, same answer for cosine of 45. And then opposite over adjacent for tangent would be 1 over 1, or just 1. Okay, now believe it or not, these are going to help us build the unit circle. Okay, because remember, that unit circle that we built was all based on the 30, 60, 90s, and we were just in different quadrants measuring from the unit circle's standard position from the positive x-axis. Okay, all right. So let's start building that unit circle. All right. So what we have here is we have our unit circle. Again, we're going to find the values of the x and y coordinates. Okay, here we go. So this coordinate right here, okay, let's back up. A unit circle has a radius of 1. Okay, so this from here to here, this is the 0.10. This is the 0.01. This is the -10. And this down here is the 0.0 -1. Okay? Alrighty. So what we're going to do now is we're going to try to find the values of the other points. We're going to start in the first quadrant, and you'll notice that each quadrant is a mirror of the first quadrant. Okay, so what we're going to do is we're going to take our 30-degree angle. We're going to drop this guy down. Okay. So this makes a 30, 60, 90 right triangle because this angle is 30. This angle is 90. So this angle must be 60. Okay. So if the hypotenuse is 1, then I can find the lengths of the other sides. So it turns out that the lengths of the other sides are okay, believe it or not. Okay, so we can go into a longer explanation of that in a bit, but we're just building right now. Okay, so notice that those are the values for sine and cosine of 30 degrees. Okay, so I want you to notice something, that x and y are equivalent to cosine of your angle and then sine of your angle. Remember how I said it doesn't matter how big your triangle is, the sine ratios will always be the same. So the sine ratio for 30 is always 1/2 no matter what. Okay, the cosine of 30 will always be square root of 3/2 no matter what. Now what's really cool is if you noticed, let's look back up here, that if we're dealing with 60, look what happens to our sine and cosine values. They just trade. Okay, and there's a reason for that. They're because they're complements, they add up to 180. So I actually already have, okay, the point for my 60-degree angle. Okay, so my 60-degree angle would be 1/2 radical 3/2. Okay, and using the same idea of using cosine of A and sine of A, I know that okay, 45 would have a point value of radical 2/2 and radical 2/2. Now, what I want you to notice is looking at your unit circle, we just have mirror images in each quadrant. So if this quadrant, the first quadrant, is positive, positive, and this quadrant is negative, positive, what do you think is going to happen to my points? Okay. This quadrant down here, the third, is negative, negative. What do you think will happen to my points? The fourth quadrant happens to be positive, negative. What do you think will happen to my points? Okay, so it turns out I just change the signs depending on what quadrant I'm in. So I'm going to take a moment and kind of fill that out. Okay. It's going to get a little crowded. Okay, so what you can do to make your life a little bit easier is you might want to go like to Google Images and search unit circle and see if you can find one you like, and you print it out. You'll find that I also like kind of color coding my unit circle. Don't drop your negatives. Okay, you're going to want this next to you when you take your test, when you work on your homework. Okay, I don't mind if you use a copy of the unit circle on when you take your test or do your homework or whatever. Usually I have students memorize it, or students use it enough where it just, you just kind of memorize it naturally. It just kind of happens. Oops. Okay, you'll use it so much, you'll find that the memorization might happen kind of naturally. Another thing that I told my students was to just oops, no negative there. Just write it out every time that you use it, and then you'll just kind of memorize it by default. Okay? So, that is the unit circle. Okay? Notice that it's very dependent on where you are on the circle. So now since I have this, I could say, okay, well, what sine of 225? And you would just look at it and say, oh, okay, sine of 225 is negative radical 2 over 2. Okay, so I want you to try that out. Let me give you another value. Let's do sine of 315. Oh, well, find 315. Sine is the second one. Radical 2 over 2. Done. Okay, let's do cosine of 330. Okay, then you would do radical 3 over 2. Okay, now, one of the harder things to do is actually tangent. Okay, tangent, it turns out, and you might want to like highlight this or something, tangent of an angle is equal to the sine of the angle divided by the cosine of the angle. Okay, so that's going to help us find tangent. So let's do tangent of 225. So you'd find 225 on your unit circle, and you go, oh, okay, so that's negative radical 2 divided by 2 over negative radical 2 over 2. Simplified, that's just 1. So let's try another one. Let's do tangent of 300. So you go, oh, okay, sine over cosine. So, whoops, radical 3 over 2 divided by 1/2. Simplify your complex fraction. And you get negative radical 3. Okay, now let's talk about the, let's say if you would have like 270, okay? So tangent of 270, okay? So you find that point is 0, -1. So you do sine over cosine, -1 over 0. Oops, I cannot divide by 0. So I would say undefined. Okay. All right. So that is how you build the unit circle. That is how you use the unit circle. It's really, really helpful to know it. Usually we recommend that students memorize it. However, since you're at home, just have a printed copy or maybe a picture, somewhere available while you're doing your homework. But the more that you use it, you'll find that the memorization just comes kind of naturally. Okay?